Okay, so in today's video we are going to prepare flood risk assessment map. Flood risk assessment map. So if you look at the table of contents over here, you can see that I have 7 variables: land use, land cover map, slope of the area, elevation, rainfall, drainage density, distance to road, and distance to river. These are 7 variables that you need before you can create flood risk assessment map. And if you look here, you can see that all these variables have their weight. So the drainage density, the weight is 15%. Do you get it? Imagine an area where the drainage density is very high. It means there are a lot of rivers underneath or underground. The area will definitely be susceptible to flooding. That is why we've given that one 15%. Distance to road 5%, distance to river 20%, elevation 15%, land use, land cover 10%, rainfall 25%, and now slope 10%. And there is also the risk rank over here, very high. We will come to that. And if you want to know how to prepare these maps or these layers, when you go to my channel, you see playlist over there. So I have my videos here, short here. Come to the playlist. When you go to the playlist, you see that the first playlist over here is the flood risk assessment mapping playlist. It is there. Then you view the list. When you view the list, you see that I have all the 7 variables over here. I am yet to upload the land use, land cover map. The video is ready, and by the time I'll be posting this particular video that I am recording, the land use, land cover map will be added to this particular playlist. So I have the distance to river and distance to road video. I have the drainage density video over here, and I also have the slope and elevation video over here, and I also have the rainfall, specifically average annual rainfall map over here. Do you get it? Yes, we have annual rainfall map or average annual rainfall map, where you have to combine all the years together before you can get an average one. I have that particular one over here. So I have all of them at the playlist. So when you go to the playlist, you see the videos. So I have already prepared them. So assuming you've gone through the videos and you've been able to prepare your land use, land cover, slope, elevation, and rainfall map, then let's start. So the first of all, this is the slope. You can see that it is in a stretched mode. This is what I mean. So we have to convert all of them to classification mode. This is what I mean. So you right click, then you go to properties. The symbology is already selected. Then you go to classify. Have you seen it? Classify is here. Let me format the labels very fast. Decimal places 0. So I'm already done with the slope. Elevation, the same thing. Rainfall is here. So we are moving them to stretch so that we can get 5 classes. So if your classes are not 5, you can come here, then you make it 5. Do you get it? So that we can get 5 classes for the analysis. And here I'm just reducing the decimal points to 0 so that we can get definite numbers or definite figures. Yes, so now the layers are here, the variables are there. The first thing that we have to do is that we have to do reclassification. So we have to reclassify them. So to reclassify them, this is what we are going to do. you go to the search bar, then you write reclass. So you see reclass. Reclassify, Spatial Analyst. Have you seen it? Reclassify, Spatial Analyst. Then you select that one. So when it comes like this, the first one we are going to look at is the land use land cover. So you select the land use land cover. And when you select the land use land cover, there are 3 classes. So the assumption is that, or the rule is that, the first one is developed area, and with developed area, the assumption is that there is moderate flood probability at a developed area. Do you get it? There is a moderate flood probability. If when we come to we talk about the probability of flood occurring at a developed area or urban area, let me put it like that, it is moderate. Do you get it? And when you come here, the moderate figure is 3. So we are going to write 3 over here. And the second one is vegetation. And with vegetation, the probability of flood occurring at a vegetative area is very low. And when you come here, the very low figure is 1. So we will come here and give this one 1. The last one is bare land. So the probability of flood occurring at a bare land area is high, and that figure is 4. So we come here and we give that one 4. Do you get it? So we've done the reclassification. Then we want to specify where we want to save it. So you come here. I am locating the folder. Reclassify. LULC. Reclass. Save. Then you check this. So the reclassification for land use land cover map is done. The next thing that we are going to be is slope. So you go to reclassify, then you select slope. So with slope, have you seen this is the values of the slope over here. Do you get it? Even though we've rounded it to 0 significant figures, but we are still seeing it here 1 point something something. So the highest value is at the down here. These are the highest value, and the top one is the lowest value. But we are saying that the lower the slope of the area, the higher the probability of flooding. Do you agree with me? Yes. So the higher the slope of the area, the lower probability that that area will experience flooding. Do you get it? But here we are seeing that the higher the slope of the area, the higher the probability of flooding. So we have to reverse it. So we've reversed it to make it align. That's the lower the slope of the area, the higher the flood of the area, the flood probability of the area. Have you seen it? Have you understood it? So we will come here again and write slope reclass. Then we check this one. Okay, slope is done. Let us go to the next one, which is elevation. And with elevation too, we have to actually reverse it. We have to actually reverse that one too, because we are saying that the higher the area is elevated, the lower the probability of flooding. Do you get it? So we have to reverse it, and the lower the higher. So we've reversed that one too. Elevation reclass. I think it is too long. check this. Okay, now the next one is rainfall. So rainfall is here, and with rainfall you wouldn't have to reverse it, because indeed the higher the rainfall, the higher the flood probability of the area. Have you seen that? If an area experiences higher rainfall, there is a high probability that the area will experience flooding. So we wouldn't have to reverse it, we will maintain it. Then we will go here, then name it rain reclassify. Are you getting the logic? Then we will look at drainage density. Drainage density too, we would have to maintain it like that, because the higher the drainage density of an area, the higher the probability of flooding of the area, and the lower the drainage density of an area, the lower the flood probability of the area. So we will maintain it like that. Then we will come here and write drainage density. Oh, it's too long, so let me write DD, drainage density. Check this. Okay, the next one that we are going to do is the distance to road and distance to river. Yes, we are saying that the lower the smaller the distance between an area to a road, the higher the probability of flooding, and vice versa. So you have to reverse it. If your house is closer to a road, there's a probability that you will experience flooding than someone whose house is far away from a road. Do you get it? Yes, this is because of the impervious nature of roads. It covers the earth's surface, so the rain will find it difficult to be to immerse beneath the earth's surface. Do you get it? That is it. That is the scientific reason behind it, why we are saying that. So we've reversed it. So we will come here, distance to road. Oh, the distance to RO. Check this. Okay, the next or the last one is the distance to river. It is the same thing. If your house is closer to a river, that is understandable, definitely. So you have to reverse that one too. Do you get it? Then we come here, distance to river. Check this. Okay, have you seen it? So we are done with the reclassification. So let me just regroup them to, so this one, you let me maintain this like that. Let me maintain them, but I want to remove the previous ones. Do you get it? I want to remove them. So now we have the reclassified versions. So now that we want to, now let us go to the flood risk analysis. So we will go to the ArcToolBox. So the ArcToolBox is here. Then we will go to the Spatial Analyst 2. Then we will go to the overlay. So we are going to use the weighted sum. So the weighted sum. Then we will select all of them. So all the 7 variables have been selected and dragged here. Do you get it? So distance to river. What is the weight of distance to river over here? distance to, let us start with a list. So drainage density is 15%. Drainage density is 15% drainage density, so we are going to give it 0.15. Do you get it? Next on the list is distance to road, which is 5%. Distance to road, 5%. Distance to road, so that will be 0.05. Next on the list is distance to river, and distance to river is 20%. Distance to river. Oh, distance to river 0.20. Next on the list is elevation, which is 15%. Elevation, so that one will be 0.15. Next on the list is land use land cover map, and that one is 10%. Land use land cover 10%. LULC 0.10. Next on the list is rainfall, which is 25%. Rainfall 0.25. Next on the list is slope, which is also 10%. 0.1. Now let us do something. Calculator is here. So 0.2 plus 0.05 plus 0.15 plus 0.25 plus 0.15 plus 0.1 plus 0.1 equal to 1. Do you get it? Which means all these will be summed up to 100%. So I just wanted to confirm that. So we are good to go. Now that we are done, we'll go here and write flood risk assessment map. Save it. Pack. Do you get it? So now we are done. So we can uncheck all these. Can uncheck this. So this is the flood risk map of the Tafo municipality of the Ashanti region of Ghana. So let us go to the layout view. Layout view. So we can go to the symbology, then reduce it to 5. We can format the labels. Then we get something like this. So here we can just rename it to very low, very low, low, moderate, high, very high. Do you get it? So it means this area is the lowest of the area to experience flooding. If flooding will ever happen at this district, then it will be around this area, but this area is far away from flooding. Do you get it? Yes. So that is it. So we can design it think the colors doesn't correlate with the descriptions. So here I think it should be like this, or don't you agree? Maybe this one should be have you seen it? Yeah, so that the red color would depict it very well. So now let me insert the legend again. So this is our flood risk assessment map of the Kwofae municipality of the Ashanti region of Ghana. I hope you enjoyed the video. Kindly help me with a subscription, a like, a share, and you can comment so that this video can go far. Just do it for me, for the efforts I've been putting in to help you also learn. Thank you very much for watching, and I would like to see you in my next video. Bye bye.